Right, very interesting day we have here. Today we are looking at ordinary differential equation and we want to look at the solutions to a differential equation. We want to look at the solutions to a differential equation. We said to solve a differential equation, we said we have to find the function for which the equation is true. Yes, that's very certain. That's very certain. And says this means that we have to manipulate the equation so as to eliminate all the derivatives. So as to do what? To eliminate all the derivatives. So for the sake of, or for the scope of this video, we want to look at very interesting methods we can use to solve differential equations. Number one, we have what we call the direct integration. Is that okay? We have what we call the direct integration. Number two, we have by separating the variable, right? You can solve a differential equation by separating the variable. Number three, we have what we call homogeneous equation. We have what we call homogeneous. So quickly, we will be looking at the methods one after the other. Our first on the list is direct integration. So every of these things have conditions to be met. Is that okay? Every of the method you can use to find a solution to a differential equation, they have condition that you must meet. What is the condition for direct integration? It says if the equation can be arranged in the form dy dx is equal to f of x, then the equation can be solved. Yes. An example, let's look at this example. So we have dy dx is equal to 3x squared minus 6x plus 5. Did you see that? It means that this function is taking the assumption of this because we have dy dx is equal to f of x, right? Now let's integrate this. If we integrate this, we begin to have what we call, let's integrate this quickly. You have 3x to the power of 3, yes, minus 3x squared plus 5x, is that not? Plus c. That's what you're going to have. In case you don't understand what we just did here, if you integrate 3x squared, integral of this dx is 3x cubed, right, over 3. So this 3 cancels this 3. That was how we got this. If you are confused about the 6x, how did we manage to pull that through? So integral of 6x will be 6x squared over 2. So this cancels this, we'll have 3x squared. That is how it is being operated. Is that okay? Now, this method is valid. Why? Because the question came in as what? The y over dx is equal to 3x squared. The question is equal to, the y over dx is equal to f of x. That is why it was so easy for us to differentiate this function, to integrate it rather. Now, as always, let's put that quickly. As always, of course, comma, the constant of integration, you see that? The constant of integration must be included. Must be included. Must be included. Let's not forget that. This c must be included. It must be included. Is that okay? Now let's look at another example. Let's look at another example quickly. Example 2. Example 2. We're asked to solve x dy dx is equal to 5x raised to power 3 plus 4. Interesting. Interesting. X, the y dx is equal to 5x raised to power 3 plus 4. How do we go about this? All right, so my first step is to make sure I isolate this guy, which is the y over dx. So I'm going to say divide both sides by x. Is that not? Divide both sides by x. So if I divide both sides by x, I'm going to have the y over dx is equal to 5x raised to power 3 divided by x plus 4 over x. So this means the y over dx is equal to 5x squared plus 4 over x. Did you see that? Now, this function is looking like when we say the y over the x is equal to f of x, because the f of x in this case is this person, and the y over the x in this case is this person. So we can use a direct integration. You can use a what? a direct integration. So let's look at that quickly. Let's integrate that quickly. So let's integrate. This means that y is equal to the integral of 5x squared plus 4 over x dx. Did you see that? So let's integrate that quickly. You have y is equal to 5x to the power of 3 over 3. In case you want to find out what I did to become this, I said 5x raised to the power 3 over 3. How did I get that? Whenever you are integrating, for example, x to the power of n, if you want to integrate this, it becomes x to the power of n plus 1 all over n plus 1. Do you understand? All right, that is a basic calculus. Is that not? So if we integrate this, we have this, and this is likened to this 4 over x is likened to you saying 4 times 1 over x, and when you integrate 1 over x, you have a ln x. Do you understand? So you have a 4 ln x plus c. Don't forget, I said, as always, of course, the constant of integration must be included. Thank you so much. That is interesting. Now let's look at another example. Example 3. It says find the particular solution of the equation. Find the particular solution of the equation exponential to the power of x, the y dx is equal to 4. Given that, do you see that? Given that y is equal to 3 when x is equal to 0. Find the particular solution of the equation exponential to the power of x, the y over dx is equal to 4, given that y is equal to 3 and x is equal to 0. All right, so according to what I said earlier, you have e to the power of x, the y over the x is equal to 4. Let's divide through by e to the power of x. E to the power of x, e to the power of x, this cancels this. So we have the y over the x is equal to 4 divided by e to the power of x. Interesting. And so we have that the y over the x is equal to 4 e to the power of minus x. Is that not? All right. So let's take the differential of both sides. Let's take the integral of both sides. Please, if you integrate the y dx, your answer is y. Please note that here quickly. If you integrate the y dx, your answer will be y. Right? Good. So y is equal to, let's integrate this quickly. If you integrate an exponential function, just the coefficient of x comes down. So we have a negative 4e negative x plus c. Interesting. So now, knowing that x is equal to 0, let me write that down because we're not done with the question. The question says, given that y is equal to 3 when x is 0. Given that y is equal to 3 when x is 0. So we found out that let's put it into writing, knowing that x is equal to 0 and y is equal to 3, we can evaluate, you see that? We can evaluate c in this case. All right, so let's do that. So if x is equal to 0 and y is equal to 3, let's put that here. So that's 3 is equal to minus 4 because they said find the particular solution. Emphasis on this word, particular solution. So that's why we are solving for c. So minus 4 e to the power of minus 0 plus c. All right. So our answer to this is 3 is equal to minus 4 e to the power of what? Okay. Anything raised to the power of 0 is 1, right? Good. All right. So from this point, let's put it into consideration the laws of indices. So let's keep it this way. We have minus 4 e to the power of 0. So this can become minus 4 multiplied by 1 over e raised to the power 0 plus c. Okay. So we have 3 is equal to minus 4 times 1 over. The loss of indices says e raised to the power 0 should be 1 plus c. So we have 3 is equal to minus 4 times 1 plus c. 3 is equal to minus 4 plus c. So we take this to the other side. 3 plus 4 is equal to c. That's 7. It means that this simply means that the particular solution, you see that, it means that the particular solution of this function is y is equal to minus 4 e to the power minus x plus 7. Did you see that? You have solved for c. Did you see that? Is that clear? All right, let's continue. The second method we'll be looking at is method 2. How do we solve differential equation? How do we solve differential equation? Or how, solution to differential equation. We want to look at another method. We call that method by separating the variables. Variable separation. By separating the variables. So our thought on this is that what? We said if the given equation is of the form, if the given equation is of the form, the y over the x is equal to a equation containing two independent variable system, we said the variable, let's put that quickly into writing. We said the variable y on the right hand side prevents, let's put it that way, prevents solving. Did you see that? It prevents solving by what? Direct integration. So you can't use direct integration here. Why? Because the variable y is on the right hand side. Now this is left hand side, this is right hand side. So if the variable y is on this right hand side, you can't use what? Direct integration. You can't use that. So it prevents. So emphasis on the word prevent. Did you see that? Emphasis on the word prevent. So prevent solving by what? By direct integration. So we therefore have to devise some other method. Did you see that? Some other method. So where we have to devise another method is where separating variable comes to play. Did you see that? Separating variable comes to play. So I'm making the video easy for you to understand. I'm making the video what? Easy for you to understand. All right. So we therefore have to devise some other method. Now let's look at this quickly. Let's look at a very interesting example. Okay. Example quickly. It says solve. Meanwhile, all the questions we are solving so far are photo-based exam questions. So if you are from the Federal University of Technology Owerri, Owerri, it is nice to meet you. And prior to this video, if you have a question to ask me, you can ask me at 09058669385. All right, Sir Rizzy. Is that okay? All right. Example. It says solve the y over the x is equal to 2x divided by y plus 1. Wow. Interesting. Solve the y over the x is equal to 2x divided by y plus 1. All right, let's do that quickly. So we have, can we cross multiply? Yes, we can. Let's cross multiply and see what goes there. So we have the y into the bracket of y plus 1 is equal to dx into the bracket of 2x. Because I want to find the y over the x, let me divide by dx and see. Let me divide by dx. I'm making it very easy for you to understand. So I have the y over dx into the bracket of y plus 1 is equals to 2x. All right, is that not? Now you can see that the variable y is now on the what? Is now on the what's it called? The left hand side. Before, it is not on the left hand side. Can you see that it was on the right hand side? The variable y was on the right hand side. So you can't do a direct integration. If the variable y is on the right hand side, if I have w is equal to 2x. All right, so sorry for the interruption. Let's continue with what we are doing. We said the y dx is equal to this. So now you can discover that what the y variable is on the left hand side now. So you can do a direct sort of integration on this, So let's do that. The y dx is this, and then from here you can then say now let me write that quickly. Now integrate both sides. Integrate both sides with respect to x. Did you see that? So let's integrate that. So if we integrate, we're going to integrate y plus 1 y dx, right, with respect to x. Yes, let's integrate that. Is equal to integral of 2x dx. Remember, when you are integrating, you must put this dx there. Very important, very, very important. Let's integrate both sides with respect to x. So let's integrate. If you integrate this, I believe this will cancel this, yes? So we integrate this. Integration of y plus 1 to y is equal to integration of 2x dx. Is that out? All right, let's integrate that quickly. If we integrate this, we begin to have y squared over 2 plus y is equal to this is x squared plus c. The question some of you ask me, how did I arrive at x squared? If you have 2x, the x component of this can be written as x plus 1 over 1 plus 1. That's x squared divided by 2. Then multiply it by 2. So cancel out, so you have x squared. Do you understand me now? That was where we were able to find out that this is what we have. Alright, so this is a solution to a differential equation. Let's look at another example quickly. Example 2 on this. It says solve the y dx is equal to 1 plus x into the bracket of 1 plus y. Did you see that? 1 plus x into the bracket of 1 plus y. So what do we do? All right, so let's look at it together. We have let me divide through. So let's divide through by 1 plus y. Let's divide through, because our major aim is we want the variable y to be on the left hand side, because if it's on the right hand side, it will be difficult for us to solve the problem. Do you understand? So let's do it quickly. Let's divide through. So we have the integral. And first of all, before you integrate, let's do 1 over 1 plus y, the y over the x is equal to 1 plus x into brackets 1 plus y divided by 1 plus x. So let's divide. If we divide through like that, so this is, we have 1 over 1 plus y, the y over the x is equal to 1 plus, sorry, I'm dividing through by y, 1 plus y, sorry, that's a mistake. 1 plus x is here. So I'm cancelling out. So we have 1 over 1 plus y, the y dx is equal to 1 plus x. Did you see that? So now we can now integrate both sides. It says integrate both sides. Integrate both sides with respect. Integrate both sides with respect to x. Did you see that? So let's integrate both sides. So we have integral of 1 over 1 plus y, the y over the x dx is equal to the integral of 1 plus x dx. Did you see that? So we have okay, this cancels this as usual. we have ln 1 plus y is equal to x plus, so if you differentiate 1, it becomes 0, but if you integrate 1 dx, it becomes x. Do you understand? So in differentiation and integration are words and opposites. Is that okay? So let's integrate this. We have x plus x squared over 2 plus c. Please don't forget to add this arbitrary constant. It is very, very important. It is very, very important. Did you see that? So we use separable variables. We use separable variables. We use separable variables when we discover that you can integrate f of y dy is equal to f of integral of f of x dx. You see that? Now we're going to do something very interesting right now. Something very interesting, something very calculative. A very good example. Example 3. We have the y dx is equal to 1 plus y divided by 2 plus x. Wow, this looks quite difficult, right? Looks quite difficult. How do we solve this problem? The y over the x is equal to 1 plus y divided by 2 plus x. Wow, interesting. So our major focus or our major aim is to make this guy be on the left hand side. So let's cross multiply and see something. We have the y into the bracket of 2 plus x is equal to the x into the bracket of 1 plus y. Okay, we still have a problem there. Let's divide through by 1 plus y. Let's divide through by 1 plus y. This cancels this. So we have 2 plus x divided by 1 plus y is equal to dx, which is not what we are looking for. Is that not? Dx. There's a dy here. Let's not forget. Okay, so what do we do? Okay, multiply through by 1 over 2x. Let's multiply through by 1 over 2x. So we now discover that we'll have the y multiplied by 1 over 2 plus x multiplied by 2 plus x divided by 1 plus y is equal to dx multiplied by 1 over 2 plus x. You see that? So this one can cancel this. So we have the y into the bracket of 1 over 1 plus y, right, is equal to dx multiplied by 1 plus 2x. See that? Is that okay? Are we following at all? All right. So we have integrate both sides. Let's integrate both sides. We have the integral of 1 over 1 plus y dy is equal to the integral of 1 over 2x dx. As you can see, it is now looking like something that you can use separable variable for. You see that? Because you'll be able to separate them. Y is on the left hand side, x is on the right hand side. You see that? Making sense now, right? Good. Now, let's integrate both sides and see. If we integrate both sides and see, we now have ln 1 plus y should be equal to ln 2 plus x plus c. Glory to God. Is that not very, very interesting? Very, very, very beautiful. Very, very beautiful. Very, very beautiful. Is that okay? Now let's take one more example on this. Example 4. And we call it a day on separable variables. Example 4. Solve the y over the x is equal to y squared plus xy squared divided by x squared y minus x squared. Wow, this is a photo question. Thank you. 2017. Wow. Let's solve the y over the x is equal to xy squared plus xy squared divided by x squared y minus x squared. Wow, interesting. So let's factorize. we have the y over the x should be equal to, what is common to both sides? Y squared is common to both sides, I believe. That's 1 plus x divided by, what is common to both sides here? X squared is also common to both sides, I believe. Y minus x. Okay, no, y. Okay, minus 1. Let's do it, a minus 1. Yes, because this is common to both sides. X squared. Yes, minus 1 is okay. Minus 1 is okay. All right. Interesting. So what do we do from here? All right. So what do we do from here? We try to cross multiply quickly. Let's cross multiply. So we have the y multiplied by x squared multiplied by y minus 1. The reason why I'm doing this is to make it easier for you. The x into brackets y squared into brackets 1 plus x. Did you see that? So let's divide through by y squared because I want y to be in the left hand side, LHS. Do you understand? So let's divide. This goes there and I have y squared here. Is that not? So what I have now is the y multiplied by, can I say y minus 1 divided by y squared multiplied by x squared is equal to dx into the bracket of 1 plus x. So I want every x to be on this side. I want every y to be on this side. So let me multiply through by 1 over x squared. If I multiply through by 1 over x squared, it means that the y into the bracket of y minus 1 divided by y squared is equal to dx into the bracket of 1 plus x divided by x squared. Good. Now let's integrate both sides. Integrate both sides. So we have the integral of the y minus 1 over y squared is equal to the integral of 1 plus dx. If you integrate, please always make sure you add your dx. Is that okay? No, sorry. Integrate this. We have integral of 1 plus x over x squared dx. Did you see that? All right, so let's integrate that. What do we have? This becomes we have integral of, let's look at this, 1 over y. Because if you break this down, you have y minus 1 over y squared. You can easily write it as y over y squared minus 1 over y squared. Is that not? So this cancels one of these. So you have 1 over y squared, 1 over y minus 1 over y squared, right? So we don't want to do that. Let's just do it this way. 1 over y minus 2. Why did I get that? Let me explain. Y over y squared minus 1 over y squared. This cancels one of these, 1 over y minus, according to the law of indices, you can write this as this. Do you understand? So that's how we have it there. Okay, so we have the y is equal to the integral of, let's look at that. That's okay. Don't need to bring the integral of. If we have this, we have ln. This becomes, let me break this down. This becomes x minus 2 plus, yes, integral of x minus 2 plus 1 over x. How did I get that? Let me explain that quickly. So you have 1 over x squared. By law of indices, you can do this, right? That's what we have there. And the next one you have is x over x squared. By law of indices, you take here 1, so 1 over x. Do you understand? So you can just, so this is this. So at the end of the day, we have, if you integrate 1 over y, you have ln y. Do you understand? Good. So plus, let's see, if you integrate this, minus 2 plus 1 divided by minus 2 plus 1, what are you going to have? This is a minus 1, right? Okay, divided by minus 1 Okay, okay. So this is minus into the bracket of y raised to power minus 2 plus 1 divided by minus 2 plus 1. Are you following? I want to break this down. It's equal to, if you integrate this, you're going to have um, x minus 2 plus 1 divided by minus 2 plus 1 plus ln x. See that? Plus ln x plus c. So let's finish that quickly. We have ln y minus y minus 1 divided by minus 1, right? Is equal to x minus 1 divided by minus 1 plus ln x plus c. So we have ln y minus times minus is plus. So we have ln y to the power of minus 1 is equal to, this is minus x raised to the power minus 1, yes, plus ln x plus c. We now have ln y. I'm purposely breaking this down for the sake of this video so you can understand what we are doing. Is equal to, let's bring this onto the front, ln x, right, minus 1 over x plus c. You see that? Interesting. Interesting. This is beautiful. This is beautiful. This is very beautiful. So our final answer is ln y plus 1 over y is equal to ln x minus 1 over x plus c. Interesting. Very interesting math. Very interesting math. Let's look at one more example on this quickly. All right, sorry for the interruption. Let's look at something more interesting and then we call it a day on these two methods. Example says solve. Let's look at this. Y over dx is equal to y squared minus 1 over x. It means that the y is equal to, let's not waste time, y squared minus 1 over x dx. How did I arrive at that? You should know that by now, right? You should know that by now. So let's rearrange. We have 1 over y squared minus 1. The y is equal to 1 over x dx. Is that not? Yeah. So we have the integral of 1 over y squared minus 1. The y is equal to the integral of 1 over x dx. Okay, so we have 1 over 2. These are special integration. These are special integration. Whenever you want to integrate this kind of function, you can say 1 over 2 ln y minus 1 divided by y plus 1. Very soon we'll be doing a special series on integration so you can understand this. You can understand what happened here. 1 over 2 ln y minus 1 over y plus 1 is equal to ln x plus c. Did you see that? So these and many more are we going to be looking at very soon. We'll be looking at this. So in our next class, we want you to be able to understand we want you to be able to understand other methods used to find the solution to a differential equation. For example, in our next method, you will now see me talking about method 3. You see me talking about homogeneous equation. Do you see that? Homogeneous equation. But that's not in the scope of this video. See you in our next class. Thank you so much.